Okay, AP Unit 27 is composite functions. So we're just like a heads up what's coming towards you. We're going to do 2.8 and 2.9. So we'll do notes Monday and we'll do notes on Tuesday. And then we won't Wednesday, Thursday, we'll just review. Wednesday, Thursday, Friday, your test is the following Tuesday. But with everybody being out between Transfig and all that stuff, and I'm not here Wednesday, Thursday, Friday for a conference. So I'm just leaving literally review. Okay, so we're going to do notes Monday. Tuesdays is logs. Like, can you find log base 5 of 25? It is that easy on Tuesday. I could leave it like without having to teach. It's the first AP classroom one that I think I could give you right now, and you'd be able to get your answers, which is the good thing. And then it gets further into logs after that. We do more with logs, but we'll do that after the next test. Okay, so your next test, which will be a week from next Tuesday, will be 2.5 to 2.9.
Do not have a quiz.
You don't have a quiz. Yeah, I couldn't figure out a way to put it within those days. Yeah. All right, so composite functions is what this section is. These are all the things that you can do with functions. I can do these with algebraic parts of a function, meaning an equation. I could do this with actual values where there's a number in where that x is. I can combine, add, subtract, all those things with graphs of functions. We are going to focus on this section as combined functions or composite functions, which is the thing on the bottom. That f(g) of x or f of g of x is how that's written. Or if it was reversed. So this is what we're going to focus on, f of g of x or g of f of x. And the order is important because that means we take f of x and we plug it into g of x. Whereas this one, if g is second, you're taking the g of x and you're plugging it into the f of x. So we're going to, like I said before, do this with algebraic stuff. So it'll say, like, here's an expression, find f of g or g of f. You're going to find it with actual values. And then we're going to learn how to find it with graphs, which is probably the only thing that's a little bit different. So example 1 says, find a f of g of x and then b g of f of x and the domain of it. So we're going to start with f of g of x, which means we take the g and we plug it into the x of the f of x. So this would be 2 times x squared plus 1 or 2x squared plus 1. Questions? Okay, so the rule on the domain, and this is important because it's not obvious all the time, is that if you have a composite function, so you're taking one and you're plugging it into the other, you have to check for the one that you're plugging into, or that you're plugging in. So if I have f of g of x, I have to check the original g of x for a restriction. And by restriction, I mean, is there a variable in the denominator? Is there a variable under square root? So we have to check that one, and it gets carried down. Even if it gets changed after it's plugged in, that initial one has to be part of your domain at the end. So 1, you do the initial one. Domain, restriction. 2, you check the composite one or the new one for additional restrictions. So you have to check the one you are plugging in. The one second, the one after the open dot, that one. I would check g of x for any kind of restriction. Then I would actually plug g of x in, and then I would check that new expression for any additional restriction. And again, restrictions, we're talking about variable in the denominator. And for those, we say it cannot equal 0, or variable under square root. And for those, we say greater than or equal to 0, or the combination of them. And for those, we say it has to be greater than 0. It can no longer equal 0 because it's in the bottom. Okay, so having said that, look at what we just did. We took g of x, we plugged it into f of x. So I go back to my original g. Is there a restriction on x squared? No, so I don't have to carry anything down. Then I check my composite function, the one I just made, 2x squared plus 1, and I say, is there a restriction on that one? There is not. So the domain of this would be all real numbers. or negative infinity to positive infinity. All right, B is the reverse. B says switch that order. So, yep. So I'm going to do g of f of x. This time I'm taking x, or f of x, and plugging it in. So I'd get 2x plus 1 squared. You can either expand in FOIL or use your shortcut. Shortcut is square the first one, so 4x squared. Double the product, so 4x, and then square the last one. Again, if you don't remember it, you just expand in FOIL. And because we did f into g, we go back to the original f and check it for a domain restriction. Is there a domain restriction on f? No. And then we check our composite function. Is there a domain restriction there? No. So my domain, again, all real numbers or negative infinity to positive infinity. Questions on that one? Okay, example 2. So now you're finding f of g and then g of f and domain again. So if I start with A, f of g says take g, plug it into f. So I get 1 over x plus 3. Then I need my domain. So I check g. Is there a restriction on my original g function? No. Is there a restriction on my composite function? Yes. Now x can't equal what? Good. X cannot equal negative 3 in interval notation, negative infinity to negative 3, and negative 3 to positive infinity. Again, if it's multiple choice, you would know which format that's given in. And if it's open-ended, I believe, unless it says specifically use interval notation, it would take either one of those. So you can write it either way. I would assume this kind of question would be multiple choice, though. Okay, B, g of f of x. This time, the f is getting plugged into the g. So this becomes 1 over x plus 3. Now I go back to the original f function. Is there a restriction on that? What is it? X cannot equal 0. So even if I have a new one or if I don't have a new one, that still gets carried down to my answer. I look at my composite and it's the same restriction. So I only need it once. Negative infinity to 0 and 0 to positive infinity.
Wait, if it's a variable under square root, it's just greater than?
No, it can't equal. Oh, wait, sorry, variable under square root? Yes, greater than. Variable under square root in the denominator, greater than. So if it's just under the square root, it can be greater than or equal to. If it's in the denominator, it can't be equal anymore. Question so far? Okay, then you're going to start to see this delivered in a different way. So on the left, you've got a graph of a function. On the right, you've got the actual data from that function. A said, well, the directions say use the graphs of f and g to find A, f of g of 2. So I start, as normal, with the innermost parentheses. I want to find g of 2. G is the table of values. My 2 is here, and the x that or the f of x, sorry, g of x in this case, that matches it is 2. Then I want to find f of that answer, and f of 2, I go to the graph on the left. I find where my x is 2, and the corresponding y there is 0. Yeah. So only the last answer. It's not like a two-part answer. That is your answer. Okay, same thing for B, but the answer is reversed. So I'm going to start with f of, or the question is reversed. F of 2 first. I go to the f of x, I find 2, I get the corresponding y, which is what? 0, and then I want to find g of 0. So then I go to the chart, I go where 0 is, I get the corresponding y, which is 4. So notice that the order is important. We can't change the order. Okay, now look at C. C says find f of g of 0 minus f of 3. So take it apart. I'm going to first do g of 0. So I'd get f of g of 0 is 4. Then I'm going to find f of 3. I go to the graph. F of 3 is 2. And then I want to find f of 2, which is, what's f of 2? 0. F of 2 is this one. Yeah, you got to do the graph for f. Questions on that one? All right. Oh, skipped. Now we get an equation with a graph. So it says, given f of x equals x squared minus 4 and the graph of g of x, find 2 of f of g of x when x is 1. So take the 1, plug it in for the x. This is saying 2f of g of 1. For g, I use what? The graph or the equation? The graph. So I go to where 1 is, or x is 1 on the graph. I find the corresponding y, which would be negative 2. Then I have 2f of negative 2, because g of 1 is negative 2. And I'm going to find this first, and then I'm going to multiply it times 2. So to get f of negative 2, I use what? The equation. So I'm using this. F of negative 2 would be negative 2 squared minus 4, or 4 minus 4, which is 0. And then I want to do 2 times 0, which is 0. Oops. I would say the biggest piece of advice I can give you on these is be really careful which one you grab, because it's really easy to grab one over the other, like the wrong one. And work innermost parentheses out just like you would order of operations. Questions on that? All right, then you get something called decomposing your functions. So it says given f of x equals f of g of x, decompose h of x by identifying a valid f and g. You're basically taking something that is the result of a composite function, and you have to figure out how to break it into its two parts that when I plugged one back into the other, I would get my question. The easiest way to do this is kind of like identify what your parent function is. So if I look at h of x, what would be my parent function there? It's a parabola or quadratic, right? So my quadratic could be what I plug into, and then whatever's done inside those parentheses could be what I plug in. So what I'm plugging into is what? F or G? I'm plugging into F, right? So that could be my x squared. And then what I'm actually plugging in could be what's inside that parentheses, which would be 2x plus 1. And let's check it. If I take g of x and I plug it into f of x, do I get h of x? Yes, so that works. All right, go to B. 1 over x minus 2. What's your parent function? 1 over x. So 1 over x could be my f of x. And if that's the case, what would g have to be? X minus 2. Good job. So again, to check, I would take x over x minus 2, plug it into the bottom, and see if I get my h of x, which is what you do. Questions on that one? All right, example 6 says match the correct f of x and g of x to produce the given composite functions. So you're trying to take something from the f of x column, something from the g of x column, that when I took that g and I plugged it into f, I got the one on the right. Does that make sense? Try to figure out if you could do it. See if you could do it. All right, let's start with, well, I'm going to go like right to left. So start with the one on the top. If I want to get e to the 3x squared plus 1, which of the f of x, g of x combinations are you going to use? Which f of x? The first one. Which g of x? The bottom one. Again, look, if I take this, I take this and I plug it in there, obviously I get that one. Make sense? Yes? Okay, let's go with the next one. So if I want to get e to the 6x, what f do I grab? X squared. And what g do I grab? E to the 3x. So if I take this guy, I plug it in here, I get e to the 3x raised to the second power. And when we raise to the power, we multiply, and that's where you get 6x. Yep.
Wait, how did you know, like, it was x squared for that one?
So for me, the obvious ones were like, if I had a +1 in some place, there was a sum or something, right? So like here, I had to either get it from here or I had to get it here. And then here, same thing, like you're adding something, so I have to figure out combinations there. This one had no sum. So I need to find a way to get my exponent to go to 6. There's 2's and 3's. So it was either like take this and raise it to the second power, but that wasn't an option.
Okay.
Or take this and raise it, or take this and raise it to the second power.
Right,
the other way
that's
around.
elimination.
Pretty much. Yeah. All right, then I don't think you'd get something like this to say decompose like we did with the last one, right, without having options. All right, then the last one is f of g, different color. F of g of x is e to the 3x squared plus 3. So obviously what's left, we're going to take this one, we're going to plug it into here. When I plug this guy into this exponent, I end up with 3 times x squared plus 1, which is 3x squared plus 3, and there's your exponent there. Questions? All right, last little bit, right, this last one is your graphs. So this one says, given f of x equals x minus 2, and you're given the graph of g of x, graph g of f of x. And then graph f of g of x. So order is important here. For the first one, it says take f of x, which would be this guy, and then plug it into g of x. Well, I don't know the equation of g of x, right? But if I were to take this and plug it into g of x, it would look like that, right? What happens when I take something inside parentheses and I subtract? You're shifting to the right 2 places. So I am taking the graph that's there and I am shifting every point to the right 2 places. So 1, 2, 1, 2, 1, 2, 1, 2. And my new graph looks like that. This would be g of f of x. Now the other way around says f of g of x. So I'm taking whatever this is and I'm plugging it into that x. So it would be g of x minus 2. What happens if you subtract outside the parentheses? We're shifting it down. So I take that initial blue graph and I shift everything down 2 places. Questions? So for me, the trickier-ish one was 2, because we haven't reviewed LNs, right? So, which we will eventually get to LNs, but you had an equation that had an E in it, and unless you had the multiple choice, which is one way to do this, was just literally plugging in your values and seeing which one worked, you would have had to solve it, or to solve it by LNing both sides of your equation, which we haven't covered yet. So we will eventually get there, but this kind of question, I would have said your best opportunity was to plug them back in and see which one worked. Otherwise, this is the process for solving with an E. You have an E and an exponent. You would ln both sides, the ln of E cancels out, and then you would go from there, which again, we'll review, but later. Questions on 1 or 2 here? Okay, 3 was your table, and you had to come up with your regression, and then you had to find y of 24. 4, you're looking for where they intersect. So these were pretty similar to the ones that we did on notes. Okay, and then 5. Again, regression, you come up with a model and it wanted t at 3.75. And then 6 was like that last example. You had to figure out that it was talking about a percent per day, but then at the end, it wanted it per weeks. So if it's per day and I want it per week, I have to multiply by the 7. Good on these? Yes? Okay, this one, and I definitely wanted to touch on it because yesterday we talked about how you find R's, the distance between predicted and actual, but the sign is important on something like this. The order in which you subtract it is important on something like this. So when you find the actual error, or R, it is predicted minus actual. That's why this one has a positive 0.03. Okay, it is an overestimate because the model was over the point, and to find the error, it should be the predicted minus the actual. 2 pattern. This one has a pattern. This is the one that didn't have a pattern. I had 2 slides. There were the only one without the quadratic did not have a pattern. This one obviously has a pattern. And so but it said that for 2, right? Here and here. The reason is is without the pattern, the residual plots for linear and show patterns. Therefore, this said linear and exponential models are appropriate. It's the opposite. The quadratic is appropriate. B, it said that they all looked pretty close, but it did say the car gradually speeds up and then the car comes back down. So if it's going up and coming back down, it has to be quadratic. Exponential would either always be going up or always going down, and linear would always be going up or always be going down. So while the model would have been the same, it said in this context clues, it should have been quadratic because it went up and came back down. This one, so this was your residual plot. It said because point P is, where's P? P is 175 and 23.4. So that coordinate point would have been 175 and 23.4. Your X value represented the height, right? Yeah, the height of the person. And then the arm span would have been the result. So 23.4 is not the arm span, but it was overestimated because the point is over the line by that Y distance, which was 23.4. And then the last one, this one, it's funny. It's weird of a pattern, but it's symmetric. So when you look at it, this happens. It goes here, and then it goes back down here. That pattern forms that way. Only because they were like literally opposites. Like this one was flipped here, this to here, this to here, and this to here. Was it a pattern? Questions? Okay, 6. This one wanted you to, so if you actually found what the predicted was, you had to find them, or no, they gave you the model. You found the model. I typed that in as the Y1, and then I figured out what Y1 of 6 would be, Y1 of 8 would be, Y1 of 2,000, and I had these values, and then I went to the residual plots, and I found, figure out what the residual plot would look like. One, you want the R distance, so you figure out which one was above and which one was below. If you just looked at your graphs ahead of time, these were both the same. 8 was different. So if you wanted to just skip right to 8, that's one of the ones that would have told you which one it was without having to do all that work. Questions? So note today we did nothing with calculator, right? So your test will again be in 2 parts. Stuff like this in which you would have your calculator because you'll have to either figure out your model, determine what it is, talk about the difference between overestimate, underestimate, all that stuff's going to come from here. Looking at the R squared term so that you know which one is the best model. And then stuff like today that it had no calculator.